What if the next war isn't decided by soldiers, or tanks, or even missiles? What if it's decided in milliseconds, by a weapon that thinks faster than any human, strikes without warning, and cannot be stopped by traditional defenses? China may already be there. Over the past few years, China has been quietly testing a new generation of warfare technology that military analysts say could completely rewrite the rules of combat, not just improve weapons, but fundamentally change how wars are fought. We're talking about autonomous AI-driven strike systems, hypersonic glide vehicles, electromagnetic weapons, and battlefield networks that operate faster than human decision-making itself. And the most concerning part, many of these systems don't just enhance existing weapons, they make them obsolete. Aircraft carriers, missile shields, even stealth jets, all could become vulnerable overnight. Today, we're breaking down the new Chinese weapon that experts believe could change warfare forever, and why the Pentagon, NATO, and military strategists around the world are paying very close attention. Because this isn't science fiction, this is already happening, and by the end of this video, you'll understand why this technology may become the most important military breakthrough of the 21st century. Let's begin. For decades, warfare has followed a simple rule: the side that makes decisions faster wins. Detect the enemy, analyze the threat, choose a response, strike. This cycle, known as the OODA loop, has always relied on human judgment. Even with advanced radar and satellites, commanders still needed time to interpret information and give orders. China's new weapon changes that completely. Instead of humans making decisions, artificial intelligence now does it automatically. This system connects satellites, drones, radar stations, naval vessels, and missile units into a single intelligent battlefield network. The moment a target appears, the AI evaluates the threat, predicts movement, selects the best weapon, and launches an attack, all in seconds. No hesitation, no communication delays, no human approval required. That speed creates a terrifying advantage. By the time an enemy detects the launch, the strike may already be unavoidable. Military analysts call this algorithmic warfare, battles fought at machine speed. Humans simply cannot react fast enough, and China has been investing heavily in this concept. In recent demonstrations, Chinese researchers showed AI-controlled drone swarms capable of coordinating attacks without direct human control. Each drone shares data with the others, dynamically changing formation and selecting targets in real time. If one drone is destroyed, the swarm instantly reorganizes. It's not one weapon, it's a network that behaves like a single intelligent organism. And once deployed at scale, it could overwhelm even the most advanced defense systems in the world. Imagine defending against one missile. Difficult, but possible. Now imagine defending against 100. Now 1,000. This is where China's new weapon becomes truly disruptive. Instead of relying on a few expensive, high-value platforms, the strategy shifts to massive numbers of small, intelligent, coordinated attackers. Drone swarms. China has already demonstrated the ability to launch hundreds, even thousands of drones simultaneously. But the real breakthrough isn't the number, it's the intelligence behind them. Each drone communicates with the others, sharing targeting data in real time. There is no single leader, no central control. The swarm thinks collectively. Destroy 10, the rest adapt. Jam communications, they switch protocols. Intercept half, the remaining drones change trajectory and continue the attack. Traditional air defense systems were never designed for this. Missile interceptors cost hundreds of thousands, sometimes millions of dollars per shot. Swarm drones can cost a few $100s each. That means defending against them quickly becomes economically impossible. Even worse, swarms can attack from multiple directions at once. Some drones can act as decoys, forcing defenses to fire early. Others fly low to avoid radar. A final wave targets critical infrastructure, radar stations, runways, ships, or command centers. By the time defenders realize what's happening, they're already overwhelmed. This isn't just theory. Chinese military publications openly discuss saturation attacks, flooding defenses until they collapse under sheer volume. And when these swarms are combined with AI battlefield networks, the entire system becomes autonomous. The swarm detects, the swarm decides, the swarm strikes. No human reaction time, no warning, just impact. If AI swarms overwhelm defenses, hypersonic weapons bypass them entirely. China has spent years developing missiles that travel at hypersonic speed, faster than Mach 5 or 5 times the speed of sound. But speed alone isn't what makes them revolutionary. It's maneuverability. Traditional ballistic missiles follow predictable arcs. Once launched, radar systems can calculate their path and deploy interceptors. That's how modern missile defense works. Hypersonic glide vehicles don't behave like that. After launch, they skip along the edge of the atmosphere, constantly changing direction, altitude, and speed. They can approach from unexpected angles, fly lower than radar coverage, and evade interception systems designed for older threats. By the time radar detects them, there may be only seconds left. China has already tested hypersonic systems capable of traveling thousands of kilometers while remaining maneuverable. Some reports suggest these vehicles can circle the globe before striking, making early warning systems far less effective. That dramatically changes strategic calculations. Aircraft carriers, once considered nearly untouchable, could suddenly become vulnerable. Fixed bases, radar installations, and missile defense systems could be targeted before they even realize they're under attack. And when hypersonic weapons are integrated into AI-driven networks, the timeline shrinks even further. Detection, target selection, launch, impact, all within minutes. In modern warfare, time equals survival. Hypersonic weapons remove time from the equation entirely. But China's new weapon doesn't just attack physically, it also targets something far more fragile: information. Modern militaries rely on data, GPS navigation, satellite communications, radar feeds, drone control links. Everything depends on electronics working perfectly. If those systems fail, even the most advanced army can become blind and confused. China has been developing electronic warfare systems designed to exploit exactly that weakness. These systems can jam radar, disrupt communications, and even feed false information into enemy networks. A ship might see targets that aren't there. A missile battery might lose tracking data. Drone operators might suddenly lose control. And in the middle of that confusion, a real strike arrives. Some Chinese systems reportedly combine cyber attacks with electronic warfare. Instead of just jamming signals, they can infiltrate networks and manipulate them. Imagine air defenses receiving fake coordinates, redirecting interceptors away from the real threat. By the time the mistake is realized, it's too late. This creates what military planners call an information blackout. The battlefield becomes chaotic. Units cannot coordinate. Commanders cannot see the full picture. Decisions slow down, exactly when speed matters most. And remember, China's AI-driven systems don't rely on human communication chains the same way. They're designed to operate even in degraded environments. So while one side is confused, the other continues attacking at machine speed. In that scenario, victory may go to the side that controls the electromagnetic spectrum, not the one with the most tanks or aircraft. And China is investing heavily in that invisible battlefield. Individually, these technologies are powerful, but together, they create something entirely new. Military planners call it an autonomous kill chain, a fully automated loop where detection, decision, and strike all happen without human involvement. Here's how it works. A satellite detects movement in a contested region. The data is instantly transmitted to an AI command system. Within milliseconds, the AI cross-references drone feeds, radar signatures, and thermal imaging to confirm the target. It predicts where that target will be in the next few seconds. Then it selects the best available weapon, a drone swarm, a hypersonic missile, or long-range artillery, and launches automatically. No radio call, no commander approval, no delay. The entire process happens faster than a human